Good morning, Year 10s, and welcome to another fun vodcast by Mr. Wormy & Co. Mr. NG is here in spirit today. I'm just going to run through this. Okay, so we did learn the other day what the quadratic formula was, some of us more so than others. So I'm going to run through it again and just make sure you understand. So I've written here for a quadratic equation. So whenever you want to solve an equation, one side has to equal 0. Okay, so from here, if I know that one side is 0, I've got ax squared plus bx plus c, we can use the quadratic equation to get my x values. So basically what that means my solutions or my roots on my x-intercepts. So I'm just going to make up, if I had x squared plus 4x minus 12 equals 0. If I said to you, I want you to get the solutions of this equation, you know that you'd have to factorize it. So find two things that multiply to give 12. 6 times 2 gives me 12. But one of them has to be negative because I want to end up with plus 4 in the middle. So it's going to be plus 6 and minus 2. 6 minus 2 is 4. And 6 times minus 2 is negative 12. So we can say this factorized is x plus 6, x minus 2. So that is factorized. However, if I said to solve the equation, we've got to use the Null Factor Law. And the Null Factor Law is either this bit here equals 0 or this bit here equals 0 for the whole side to equal 0, for this whole side to equal 0. So if x plus 6 equals 0, x equals negative 6. So that means if I put negative 6 into this equation, this side will equal 0. The other thing is x minus 2 equals 0, so x equals 2. These are called solutions. We could also say they're roots or x-intercepts. They're all the same thing. Okay, now why did I show you that? Because, don't forget you can always rewind if you want to see something again. Because to solve this, instead of just factorizing, something that will always work if it's going to possibly factorize is using the quadratic formula. Now, the value of a is the coefficient of x squared, so it's the thing out the front of the x squared, so it's 1. The value of b is the thing out the front of the x, so that's 4. And the value of c is the constant at the end, and you always take the sign as well. So that's going to be negative 12. We put them into the quadratic formula, and it should give us exactly the same solutions that we had before, which, if I remember correctly, were negative 6 and positive 2. So let's put them into the quadratic formula. X equals negative b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 1, times c, which is negative 12. So that's coming from this here. I'm just following this pattern, like substituting those values in. And that is on 2a, so it's 2 times 1. From here we get negative 4, plus or minus 4 squared is 16. I got minus 4 times 1, which is minus 4, times minus 12, which is positive 48, all on 2 times 1. I get negative 4 plus or minus. Now here, 16 plus 48 is 64. And when I square root 64, I get 8. So I can replace this bit here with 8. So negative 4 plus or minus 8 on 2. Then we can split it apart. Negative 4 plus 8 on 2. Negative 4 minus 8 on 2. So I'm just splitting the plus or minus apart. Negative 4 plus 8 is 4 on 2. Negative 4 minus 8 is negative 12 on 2. So I get 2 or negative 6. So then my x-intercepts, my roots, my solutions are the same thing and are exactly the same as these up here. So it works. Okay, so the quadratic formula allows you to find solutions or x-intercepts without factorizing. You just plug all the stuff in there. It does take longer, but sometimes you need to do it because you might not be able to factorize it, or you don't want to complete the square. So from here, let's use it for this one. So a equals 3, b equals -8, c equals -9. We know that x is -b, so -8, which is +8, plus or minus the square root of b squared, so -8 squared, minus 4 times a, which is 3, times c, which is -9, all on 2 times a, which we know is 3. So you get 8 plus or minus. -8 squared is positive 64. So don't forget, this will always become positive. There's no reason it would be negative, because whenever you square something negative, it always becomes positive. Then I've got 4 times 3, which is 12, then times -9. So -12 times -9 is plus 108, all on 2 times 6, which is 2 times 3, which is 6. Okay, so I've got 8 plus or minus root 172, when I add those together, on 6. 172, I know that 4 goes into it, because I know 160 is divisible by 4, and if I add 12 to it, 12 is also divisible by 4. The number of 4s into 160 goes 40, and into 12 goes 3. So that is 8 plus or minus 4 times 43 on 6. But we know the square root of 4 is just 2. So I say 8 plus or minus 2 root 43 on 6. Then we can bring out 2 as a common factor on top. So 4 plus or minus root 43 on 6. They cancel, so I get 4 plus or minus root 43 on 3. Or you could say 4 on 3 plus root 43 on 3. And 4 on 3 minus root 43 on 3. Now, luckily for you guys, your calculator can do this. You can also approximate these values. So I'm just going to write them up here. Okay, the square root of 43. I know the square root of 36 is 6. The square root of 49 is 7. So I'm going to say the square root of 43 is about 6.5. So we can approximate these values. If I've got 4 plus root 43 on 3, that's approximately, squigglies, 4 plus 6.5 on 3, which is 10.5 on 3, which is 3.5. So I'm going to say that's one answer, approximately. Then the other answer is 4 minus 6.5 on 3, which is negative 2.5 on 3. Now 3's into 2.5, or 3's into 24 goes 8 times. So we could say 0.8, but I reckon it's just a bit bigger than 0.8. So let's say negative 0.85. So they're my two solutions as decimals, approximately. The only reason you would do it approximately is if you don't have a calculator. If you're going to graph them, you'd put the exact values on, but this is how you would work out where they would be on the graph. Okay, so let's go to our CAS. We have got 3x squared minus 8x plus 9. 3x squared minus 8x plus 9 equals 0. Interactive advanced solve. Okay, 3x squared minus 8x, I think it's minus 9 actually. Oops. Okay, so that gives us exactly the same solutions that we got. 4 on 3 plus root 43 on 3, 4 on 3 minus. Now if we want them as decimals, just do the same thing and hit enter. Negative 0.85 and then 3.5, which is pretty much what we got. I was lucky. So that's how you do it on your CAS. You just use solve, and you have it in decimal if you want decimal answers, and you have it in what is it called? You have it in standard if you want it to be in square root form. So like exact answers. Okay, so here, use the quadratic formula to solve this. Then use your solution to find this. So first we've got to use the quadratic formula. So forget about this for the moment. Move it off to the side. Here, I get a equals 1, b equals -2, k, because it's the coefficient, whatever's in front, c equals 4k. Okay, so we know x is -b, so 2k, because negative 2k, plus or minus the square root of b squared, so -2k squared, minus 4 times 1 times 4k, all on 2a, which is 2k plus or minus the square root of 4k squared minus, have I buggered something out here? B squared, oh, a is 2. Whoops. So here that's going to be 2 times 2. And here that's going to be a 2. Okay, so I get 4k squared minus 4 times 2, which is 8, times 4k, which is 32k, all on 4. Now here I've got a 4 and 32, so I can take out a 4. So I get 2k plus or minus the square root of 4, k squared minus 8k, all on 4. But we know we can take that out of the square root and it becomes a 2. So I get 2k plus or minus 2, k squared minus 8k, all on 4. And then we can divide everything through by 2. So that will divide, and that will become a 2. So my solution is k plus or minus k squared minus 8k on 2. So that's our x value. Whatever the values of k are, they are going to be our x values. What they want you to see in this question is to go, okay, here I've got a 2, here I've got a 2, here I've got a -2k, and here I've got a +6. So we know -2k has to equal 6. We know that 4k has to equal -12. So if we check them, here I get k is equal to -3 when I divide the -2 across, and I also get k is equal to -3. So it's the same for both. Now it says then use this solution. So it's saying use this to then work out what the solutions are for this. So it's saying use k equals -3 in this solution to find out what our x-intercepts are. So we say x is -3 plus or minus -3 squared minus 8 times -3, all on 2 times, or just 2, because I've got a 2 here. So I get -3 plus or minus 9, 8 threes are 24, that's going to be positive, on 2. And then from here we would get -3 plus or minus root 33 on 2. And you could say -3 plus root 33 on 2, -3 minus root 33 on 2. So they're your two solutions. We can check it. We can go into here, 2x squared plus 6x minus 12. 2x squared plus 6x minus 12 equals 0. Highlight interactive advanced solve. And that gives us our decimals. So I get 3 on 2, -3 on 2 plus root 33 on 2, and -3 on 2 minus root 33 on 2. Now the other thing I should show you is from the original equation, we'll grab this. Now in the original equation we had 2 squared -2k x. Now you can't do kx like that. You've got to put you've got to put a times. And then here we had plus 4k. So whenever you've got an x and another variable, like a k or an a or whatever, you've got to put a times between them so the calculator knows that they're two different things, like they're not one variable. If we click Xe, that gives us the solutions that we found originally here. Oops. So it gives us solutions we originally found here. And then if we wanted to, oops, what am I doing? We could say, okay, here, I want to use that equation and say given k equals -3. So there's one solution. And then we can use the other one and do the same thing. So grab that, put it down there, and there's our other solution. So we've got two solutions, which are exactly the same as the ones that we had before. Okay, so that's our quadratic formula. Now we want to use the quadratic formula to find the x-intercepts, the axis of symmetry, and the turning point of the equation. Okay, so we know firstly, the x-intercepts, we know a equals 2, b equals -3, c equals -1. X is -b, so 3 plus or minus the square root of -3 squared, minus 4 times a, which is 2, times c, which is -1, all on 2a, which is 2 times 2. From here, we get 3 plus or minus the square root of 9. 4 times 2 is 8, times -1, that's going to be +8, on 4. So we get 3 plus or minus root 17 on 4, which is 3 plus root 17 on 4, or 3 minus root 17 on 4. Now we can approximate once again. The square root of 17 is about 4, so I'd get 3 plus, so we say approximately, 3 plus 4 on 4, or 3 minus 4 on 4. So here we would get 7 on 4, or -1 on 4. So it's about 1.75 and -0.25. That's approximately. It's not exact, but it's approximate. Okay, so there are x, but these are the exact x-intercepts. These values here, 3 plus root 17 on 4, 3 minus root 17 on 4. It says to find the axis of symmetry. Now, whenever you've got an equation, y equals ax squared plus bx plus c, the axis of symmetry is always -b on 2a. So whatever b is, it's -b on 2a. So here we can say it is x is -3, so 3 on 2 times 2, which is 3/4. Don't know why that's not working. Okay, so that's 3/4. If I want the turning point, we've got to complete the square. So I'm going to do that down here. So 2x squared minus 3x minus 1, y equals that. So we can say y equals, I've got to take a 2 out, so I say 2x squared minus 3 on 2x. Now I usually just move the -1 over to here. If I halve 3 on 2, it becomes 3 on 4. If I square it, I get 9 on 16. So to make this a perfect square, I've got to say plus 9 on 16. Now usually I would just subtract 9 on 16. However, in this case, I've said 2 times 9 on 16. Because I've added 2 times 9 on 16, I've got to take off 2 times 9 on 16. So in this case here, we get a 2 out the front, x minus because we've got a minus. A half of this value, and a half of 3 on 2 is that value there, 3 on 4, squared. Out here, we've got a 2 and a 16. The 2 cancels the 16 to be an 8, so I've got negative 9 on 8 minus 1. So I get 2x minus 3 on 4 squared. And then that's the same as 8 on 8. So I've got minus 9 on 8 minus 8 on 8, which is minus 17 on 8. So our turning point is 3 on 4, opposite sign because it's been moved to the right 3 on 4, and then it's been moved down 17 on 8. Now one of the things you might not know is your CAS can actually do this for you as well. 2x squared minus 3x minus 1. If you go into the main screen and then into something called conics, get rid of whatever's there, and then put in your equation. So y equals 2x squared minus 3x minus 1. Now, that's in quadratic form. Highlight it. Then click on this change to f of xy. And then we want it to be in this form. That's turning point form. So click OK. And it magically does it for us. That's kind of a way to cheat. And you also know that your x value of your turning point is also your axis of symmetry, which we found up here. So everything matches up, like it all works. But remember, you can always use a quadratic formula to find your x-intercepts. There is cases where it doesn't work, but we'll talk about in class next time, where we introduce the discriminant. So hopefully you understood this. Don't be afraid to ask Mr. NG or myself questions through Teams. I don't know if Collaborate's going to be working, so we'll see how we go. But you'll be able to watch this and try to do the work, which was set the other day. So some of the kids might have already done this, but if you haven't, we want you to finish off the quadratic formula. When you're not going to do the stuff on the discriminant yet, we'll do that next in class. Okay. Good luck with it, and we'll see you in class or online. See ya.